let's say, okay, we change the charge system to the line charge. So the Q will be changed to the integration of rho L dl. Okay, the integration of rho L dl, because Q equal to rho L dl. Next, we go to another part, which is how to determine the E field at certain point due to the existence of line charge. Okay, let's say based on this figure, I want to find out what is the electric field at this point due to the line charge here. Okay, this is a line charge, and this line charge is placed along the z-axis from this part, maybe this is z1 until z2. That is the length of the line. Okay, so I want to find what is the E field at this specific point. Using the Coulomb's law, when we do the analysis, so this is a conclusions. Okay, where we can draw two triangle, and we draw also, okay, a straight line normal to our rho L. So this is the shortest distance between the point and also our line charge, which is perpendicular. And then we define as alpha 1 here. The alpha 1 is from the negative z, okay, to our r, and then we have alpha 2 from r to the positive z. So we have two angles here. So the E field here can be simplified to these expressions. E equal to rho L divided by 4 pi epsilon naught in the brackets, okay, vector R divided by R, and then in brackets sin alpha 2 plus sin alpha 1 plus Z divided by R cos alpha 2 minus cos alpha 1 in bracket. So from this expression, so you have to understand how to relate this expression with this figure. Okay, so R here means the magnitude of our R here, and R is a vector, the unit vector, and then we have Z here. Okay, Z here because our rho L is on Z axis, but if our rho L on Y axis, this one become Y. If X also become X. So we have to modify the expressions. How we can obtain this, we will see later. Just for introductions. And this formula will be given during test or final exams. No need to memorize, but you have to understand the equations. This one also how to determine the alpha 1, alpha 2 in terms of sine and cosine. Okay, this is a z over a, and then we have b over z. So basically a is here, okay, the lowest point of the rho L, and then we have b here, the highest point of our rho L, and then we have z here. Z here is the point where our r is point out, okay, to the E. That is our Z, the point Z. So this is how we define alpha 1, alpha 2 by using a simple trigonometry principle. For example, alpha 1, sine alpha 1 equal to Z minus A divided by R square plus Z minus A square, because you want to divide by this part. This is just theorem Pythagoras. Okay, I will not discuss more about this. Well, what happens if our line charge become very long? Very long. For example, we have a transmission line. So when our line become very long, so when we go back to this figure, when your line is extended from minus infinity to infinity, okay, that means the length is much longer compared to this distant r between your transmission line and your point of interest. So basically the r is not significant anymore to the length of your transmission line. We go back here, okay, what happened to these expressions? Okay, when the line become very long, so it will almost being parallel, okay, this part. So we can say that alpha 2 is equal to alpha 1 approaching to 90 degrees or pi over 2. So when you put your alpha 1 and alpha 2 to 90 degrees, so what happened to this expression? This one become sine 90 degrees, sine 90 degrees, and cos 90 degrees. Here also cos 90 degrees. So you can see from these expressions, this will be 0. And then sine alpha 1 and sine alpha 2 is the same, which is sine 90, which is equal to 1. So this one is equal to 1. This one is also equal to 1. So 1 plus 1 equal to 2. So you can cancel out with this part. So as a conclusion, it can be simplified into these expressions. E is equal to rho L divided by 2 pi epsilon naught R in the direction of R. Right? So this is very important characteristic.